In this video, we're going to talk about how to describe the domain and range of a relation. So any set of ordered pairs, x, y, is called a relation. So there are different ways to describe relations. So in this slide, it shows you 5 different ways that we can represent the same relation. So we can list it as a set of ordered pairs. Remember that an ordered pair is an x and a y value. So this just lists out all of the x, y, and y values that are in our relation. An equation can tell you the relationship between x and y. We can plot all of the ordered pairs on a graph. We can create a table where we have all of the x values on the left and all the y values on the right. And then we can also create a mapping diagram. In a mapping diagram, once again, the x values will be on the left and the y values will be on the right. Each arrow will represent an ordered pair in the relation. So you can see each one of these arrows corresponds to one of the ordered pairs that we had originally listed out. So the set of all the inputs or x values in a relation is called the domain. The set of all the outputs or y values in a relation is called the range. So let's describe the domain and range of the following relation. So we have a set of ordered pairs. Remember that in an ordered pair, we have an x and a y value. Domain is going to be all of the x values, so we're going to look at all of the numbers that come first in each of these ordered pairs. So our domain will be 3, -4, -2, and then we have 3 again, so we don't actually need to list it again. We can just write 3, -4, and -2 for our domain. The range is going to be all of the values that come second, so those will be these numbers, because the range is all of the y values. So when we list that out, we have 5, 6, 4, and 2. So here it says to list the ordered pairs in this relation and then describe the domain and range. So remember, in a mapping diagram, the left side will be x, the right side will be y. Each arrow will represent an ordered pair. So this first arrow right here, that will be the ordered pair, 7, -1. This second arrow will be the ordered pair 7, 0. This next arrow will be the ordered pair 9, -7. This arrow will be 12, -1. And then this final arrow will be 15, 0. So if we list out the domain, that'll be all of the numbers on the left side of this mapping diagram. So the numbers, because those are the x values, will be 7, 9, 12, and 15. The range is all the y values, so those will be all of the numbers on the right side of this mapping diagram. That will be -7, -1, and 0. So now we have a table. It asks us to list out the ordered pairs and then describe the domain and range. So the ordered pairs will be 1, 1, 4, 4, and 8, 1. So now we need to list the domain. So the domain is all of the x values. So those will be all the values in this first column. So we have 1, 4, and 8. The range is all of the y values, so that'll be all the numbers in the second column. So we'll write 1, 4, and we don't need to write 1 again because that is a repeated value. So as long as you include it once, that has been included in your range. So let's list out the ordered pairs in this relation and then describe the domain and range. So here we have a graph, so each of the coordinates of the points is going to be the ordered pairs. So if we list them out, this first point is -2, 2. Then we have -2, 3, -2, 4, and -2, 5. Then we have 1, 2, 1, 3, 1, 4, and 1, 5. Now let's list out the domain. The domain will be all of the x values, so that is all of these values that come first in each of these ordered pairs. So I know we have a lot of repeated values, but remember we only need to write those repeated values once. So the values we have are -2 and 1. The range will be all of the y values, which are the numbers that come second in each of these ordered pairs. Once again, we have repeated values, so we don't need to write those repeated values twice. So we have 2, 3, 4, and 5, and then those numbers are all repeated, so we can just leave that as our range. So let's describe the domain and range of this relation. So let's look at this graph. This graph is a little bit different. It doesn't have a specific stopping or starting point. It doesn't have just specific numbers included. It actually includes a whole infinite set of numbers, right? It goes on forever, and then it includes all of these numbers that are shown right here. So when it goes on forever and basically includes all of the numbers on the number line, we say it's all real numbers. Okay, so if we look at all of the x values that are included in this, we would say all real numbers are included, and our symbol for representing all real numbers is this R with an extra line through it. So in math, that means all real numbers. So the way we write it is we're going to use set notation, which we talked about a little in 1.07 when we talked about solving inequalities. You would say the domain is x. You draw the line for such that, and then you would say x is an element of real numbers. Okay, so we say as long as x is a real number, it's going to be included in the domain. That's what that E means. That E is like x is a real number. The range is going to be y, and if once again we look at y, it's going to include all of these y values. It's going to include every number in between -10 and 10, and then it's going to include numbers beyond that. So once again, it's going to be all real numbers. So we say y such that y is an element, or y is a real number. And that is how we write that. So in summary, remember that the domain of a relation is all of the x values, or the input values, and the range of a relation is all of the y values, or the output values.